Okay, welcome everyone. This is Hossam Elwahsh. I will be showing the BCM Basic Communication Manager project design and implementation. Basically, this module has the capability to work with different serial communication protocols like the UART, I2C, SPI. It uses ISRs to achieve highest possible throughput for all these communication protocols. As you can see here, this is the project repo. You can find all the project source files in this BCM project folder. You can find everything related to documentation, like the project PDF, flowcharts, sequence diagrams, everything. Also, the sequence diagrams are done by PlantUML. You'll find the source for this in the folder. Simulation folder holding everything related to simulation like Proteus file, hex files, compiled hex files for post MCUs. I'll be showing in a moment. You can also use the quick links section to directly access some of these, like the project documentation. You can download the PDF or go to Google Docs link, which is this one. The video is this one right now. I'll be uploading to YouTube soon. The technical properties like Proteus simulation file, the hex files, and the clip file if you're using a version below 8.13 for Proteus. This is a circuit schematic. You can click on it for to see the full quality or download it. We have two MCUs, MCU1 and MCU2 for each. We have a sending LED and a receiving LED, which is toggled when this action is done. You can also use the debug tools with the switches to interact with each MCU UART module. I'll be showing this in the simulation in a moment. This is the project repo. Next, we have some pre-configuration that you can use. The app pre-configuration for both having the test string. I'll be showing what is used for this later. You have a test mode if you want to test the full function. It will act as an echo mode. MCU1 will send a test string with a number that is incremented from 0 to 9 in each send, and MCU2 will reply back with the same data it gets. So you can enable this hash define in both app pre-config, MCU1 and MCU2, and rebuild, and it will run in test mode. This one I will be, this is an added feature I will show at the end if we have time. And these are the commands that the application checks for and replies back. So it checks for a SYN string, BCM operating, and it replies back with confirm BCM operating. You can adjust these in both MCUs. Pre-configuration for the application module. For the UART, you have the end of text character, which is /0 because we're using strings. If you are going to use something else, you can adjust it to your needs. For the documentation, you can check the app flowcharts in the app layer section for each function. You can also check the sequence diagram for the full system. The first one is a simplified one. In normal mode, MCU1 will send BCM operating, and MCU2 will reply with confirm. In test mode, if you enable the test mode in the hash define, MCU1 will send a test string with an iterated count, and MCU2 will reply back with the same string. And next, MCU1 will increment the iteration variable and reset. This is a loop. If you want a detailed sequence diagram on this, you can click on the details. You will have everything for the MCU1, BCM, UART of MCU2, BCM, and MCU2 application layer. You can click here to access the full quality on the repo. And that would be it. I'll be moving quickly to the simulation for the sake of video duration. For the simulation, this is built for the normal mode, which is a required function. Initially, all the LEDs are off, so going frame by frame. MCU1 will send BCM operating, and MCU2 will reply back with confirm. So at BCM operating, confirm, all the LEDs are toggled, meaning that this one sent and received data, and this one sent and received data. Quickly, if you wanna, for now, this is the requirements. If you want to stop the video right now, it's okay. I'll be continuing to show the test mode if you want to test it. So for the test mode, you will enable the test enable macro for both MCUs. So add pre-configuration in MCU2 folder. Sorry. And I'll quickly rebuild. Okay, I'm sorry, something's wrong with this. Okay, I quickly enabled test enabled for both MCUs. And rebuild. Run the simulation again. You should see that MCU1 will send a string containing an iteration number, and MCU2 will reply back to MCU1 with the same string. Then MCU1 will increment this number as 1 and reply back. If you let it go, it will keep sending and receiving the same data to reset when it reaches 9, it will reset back to 0 and continue sending the data. And you'll also see the LEDs for send and receive toggles all the time. How to use these if you want to interact with MCU1 without MCU2 doing anything, you can remove all these, connect only the U2 simulator to MCU1 and interact directly with MCU1. An added also feature to the application code, if you want to modify it for the app private and the app.c in the non-test mode. We have a private enum called match ID. You can fill it with whatever IDs you want. I have 2 IDs, send command, which is BCM operating, acknowledge, which is BCM, confirm BCM operating. And also in the pre-configuration for the app, you have the match size, which is how much you wanna check for, how much strings, and the string itself. So there are two strings, 2 enums. In the application, you will just need to fill the string matches structure with IDs with the strings that you want to match. So, for example, this structure has match with, which is a pointer to a string, match ID, which is one of these. Matched is a flag if it matched the received data or not. So I'll initialize these in the app init, and the application itself checks for that for all the received data from BCM. So BCM receive goes to passes the application pass it the data received to a private function called appDQMatch, which returns a match ID. This match ID is switched to one of these enums, where which the application will do something. So if I receive the send command, which is BCM operating, I'll reply back with BCM confirm BCM operating, which is this str. This app send string uses the BCM to send the data, so BCM send in. This might be somehow overwhelming. I'm just trying to really quick show it for the video duration, so just feel free to skip it and just stick with the requirements only. Thank you for watching. I'll be uploading this to YouTube and submit